Hey everyone, welcome to Machine Learning series. In today's video, we are learning about regression. So let's get this started. So what is regression? Regression is a supervised learning technique used to predict continuous numerical values based on one or more independent features. It helps to make better decisions by finding relationships between variables. There are two types of variables in regression. One is independent variable and the another is dependent variables. For example, regression can be used to predict a stock price, house price, and so on. It helps to answer questions like what will be the value of x given y. Types of regression. Now let's talk about the types of regression. The first is linear regression. It assumes a linear relationship between dependent and independent variables. The example is like predicting height from age, weight from age, and so on. The next is multiple linear regression. This is same as the linear regression but with multiple input variables. The example is like predicting the price of house based on multiple features like location, room size, and so on. The third is polynomial regression. It is used when there is non-linear relationship between variables. The example can be modeling growth curves in biology. Another is ridge and lasso regression. These are regularized versions of linear regression. They help avoid overfitting by adding penalties to the model. Support vector regression (SVR). SVR has same concept as support vector machines, but it is for predicting continuous values, and it tries to fit the best line within a margin of error, and it is good for high-dimensional data. Decision tree regression. It uses a tree-like structures to make decisions. Random forest regression. It is an ensemble method which builds multiple decision trees and averages their predictions. It reduces overfitting and increases accuracy. Regression evaluation metrics. Here are some of the evaluation metrics for regression. Mean squared error (MSE). It is the squared difference between actual values and the predicted values. Root mean square error (RMSE). It is the square root of mean squared error. Mean absolute error (MAE). It calculates the average absolute difference between predicted and the actual values. R-squared core coefficient of determination. It measures how much of the variance in the target variable is explained by the model. Higher values is better fit, ranging from 0 to 1. Regression workflow. Here's how a regression model works. The first is collect the data. Here we gather data, that is independent variables and dependent variables. The second is pre-process the data. We handle the missing values, normalize and split into train and the test datasets. And the third is train the model. We use an algorithm like linear regression to learn patterns in the training data. The fourth is make prediction. The model predicts new outputs based on unseen inputs. The last is evaluate the model. We evaluate the model to measure how accurate the predictions are. So this is the workflow of regression. The real-world applications of regression are in finance, such as predicting stock prices, interest rates, and so on. In energy, such as forecasting electricity demand. In business, such as inventory planning, sales and revenue forecasting. In healthcare, such as predicting patient result or recovery time. In agriculture, such as estimating crop production. Advantages. Let's see the advantages of regression so it will be easier to understand when to use it. The first is it is easy to understand and implement, so it is great for beginners. Fast and efficient. It is fast and efficient because regression models can train fast even on huge datasets. It works well for linearly related data. Disadvantages. Sensitive to outliers. They can be sensitive to outliers. Can underfit complex data. Simple regression models may miss patterns in complex datasets. That's why it can lead to low accuracy. Need attention in pre-processing. There needs an attention in pre-processing because regression is affected by missing values, non-normal data, and so on. Okay, that's all for today. We understand regression is a powerful tool in machine learning to predict continuous values. We now know how regression works, the types of regression, and the common algorithms. Thank you for watching this video. In the next episode, I will explain what linear regression is. So stay tuned. If this video is helpful, do not forget to like, share, and subscribe, and hit the bell icon so you'll never miss a video. I will see you in the next video. Thank you for watching.